This is our demos today. We have a parking sensor communication to WR322EC through LoRaWAN. And our computer use the Ethernet cable connect to WR322-EC. And also, we can configure the parking sensor first through the USB to 3-pin UART cable. For example, you can change the upload interval and other settings. Okay, you can refer the user manual of parking sensor to configure the parking sensor. Okay, and in this page, we open the parking sensor case to show you how to connect the cable. You can see we need to connect the battery and the capacitor and a 3-pin UART cable if you want to make some configuration. The 3-pin are TX, RX, and the ground. You can find the serial parameter and the pin assignment in the sensor datasheet or user manual. By the way, we can use the magnetic in clockwise direction to reboot sensor, so we don't need remove battery every time. Okay, now we start to edit the parking sensor info in the WR322EC. We need to open the browser and input the HTTP and the IP address of WR322EC and the port 8088. Then we click LoRaWAN server and click application and click edit application. You can see we have already added the application parking sensor. Then we can click devices button and continue edit the device. And we already added the devices parking sensor 01. You need input device EUI when edit device. And you can find it in the button of parking sensor. After edit the device, we click activation. Select join mode to the OTAA and input the application key that you can also find in the button of parking sensor. After you input app key, then click submit button. Because the minimum upload interval of parking sensor is 1 hour, so after configuration, we can use magnetic to reboot parking sensor to check it quickly. Then we back to the application devices to check the field. Let's see at it. If you can see the timestamp here, means the parking sensor already connect to WR322EC successfully. And we have another choice to check the connection. We can open the browser and go to the CryptStack web page of WR322-EC to see the detail. The CryptStack web page is HTTP with the IP address of WR322-EC and the port 8080. And you can use the admin to log in the CryptStack page. And you can click the gateway and click the WR322-EC-LoRaWAN-default. Then select Live LoRaWAN Friends. Okay, so if you didn't see anything here, Again, you can use the magnetic to reboot parking sensor. In slowly, you will see the LoRaWAN frame uploaded by parking sensor and display here within 1 minute. Okay, next, we will go to the WR322-EC no-rate web page with the HTTP, the IP address of WR322-EC and the port 1880. And you will directly see the default flow for parking sensor. We will explain how to process MQTT data in Node-RED. In the left side, you can see we have dragged a MQTT-in node. We can double-click to edit this node. We need to change the topic. The format is application / the ID of parking sensor / device / and the device EUI of parking sensor and with the /sharp in the end. Okay, so we can back to the LoRaWAN server and the checker application. You can see the here is a parking sensor. The ID is 36, and here it's the device EUI of parking sensor. Okay. And after you change the topic, remember to click the done and the deploy. And you can see we have dragged the two debug node here in green color. We can click the pull ring to active or deactivate the node. When we activate the debug node, you can see the debug message to output to right side by click the bug icon. In first debug node, the message .payload. Every time when WR322-EC receives data from parking sensor, it will display in debug window. In second debug node, the after decoder, it will output the data after decoder. The original upload data needs translation to feed to Sync Master OTA. The debug node will help to check the decoder correct or not. Okay, so now we use magnetic to reboot the parking sensor again. Okay. So you will see now the parking sensor will upload data to the Node-RED and display in the debug windows in the right side. Okay, so you can see the debug node, the debug windows display again, and this one is output by the first debug node, and the second one